Thanks for tuning in to the Lean 911 podcast, where you'll have a voice directly from the Gemba. I will rely on my 3 decades of Lean successes as well as my failures to answer your most challenging questions regarding your Lean transformation. I'm your host, Mark DeLuzio, President and CEO of Lean Horizons Consulting and the Principal Architect of the Danaher Business System. Looking forward to your questions. Now, let's go to the Gemba. Hello, everybody. Episode 81. Wow, we're approaching that 100 episode mark pretty soon. Seems like yesterday that we just started this podcast called Lean 911. Again, for you guys out there in foreign lands, 911 is the United States emergency number when you have an emergency, a fire, a medical situation, whatever. So I know it might be different in your country, but anyway, that's what we decided to call this. This episode, this has been something I've been seeing for a long time. And amongst the different 80 or so episodes, I've mentioned this here and there, but I want to focus specifically on it. This episode is called Your Machines Are Lying to You, and So Are Your Equipment Vendors. The hidden waste most manufacturing engineers ignore. Now, I know what you're going to say. I know, especially the engineers might get a little defensive, but and okay, rightfully so. Maybe you're not that guy or gal that ignores these kind of things I'm going to talk about, but from my experience, most have. So, yeah, your machines are running. That's great. I'm sure you're focused on some kind of OEE metric, which I am vehemently opposed to for a lot of different reasons. Matter of fact, episode 61 talks about OEE and absorption accounting. They have the same effects on your behaviors. And go back and listen to that one because I am adamantly against the OEE calculation. So many people argue with me about that, but hey, that's just the way it is. I have not seen it help anybody service their customer. Okay. It serviced their internal metrics, but not their customer. But there's a lot of waste in equipment, right? Feeds are too slow. Speeds never challenged. So many times we're cutting parts too slowly for whatever reason. Cycle times that have quietly crept up over the years. And nobody asks why. Nobody even seems to notice that that's a problem. Okay. Most manufacturing engineers don't see this, they don't look for it. We spend hours and hours optimizing value stream maps and doing all the things that we think we're doing with lean and focusing on this never ending quest for productivity, which I have an episode on that too. If I could find it, I should have wrote all these down. But, I basically have an episode that says stop measuring productivity. That's episode 69. Go listen to that one and find out why I think you should stop measuring productivity because that's a lagging indicator, and there's all kinds of things that productivity number will tell you that it's too late. If you're at that point, it's too late. Okay. Uh, we debate layouts. We look at all these different improvements, but we very rarely open up the machine door and say why. Why is it running this way? Is this really a lean concept in terms of how we program this thing? Okay. And then capital equipment locks those wastes into place. You end up buying bigger machines instead of smaller equipment. And I'll talk more about that later. Uh, Basically, the waste gets engineered into our process. And we don't really look at this. Okay. So we're going to talk about the waste that equipment has. Why do engineers miss it? And how to start designing and running machines that support lean instead of fighting it. All right. If your machines aren't improving, all they're doing is hiding waste. Now, I've been hard on engineers. Episode 72, I talk about where are the engineers? Because every time I walk into a factory, I ask the question, how many engineers do you have? Normally, it's a very low number, and I would probably challenge you to look at the number of accountants you have, or people who handle materials, okay, or people in the supply chain, and then ask how many manufacturing engineers does this company have compared to those headcounts? Usually it's underfunded, and usually the engineers do not have the requisite skill sets for the business that they're in. I was in a business that had all kinds of cutting dies and and all kinds of champering and turning. And I said, "Do you have any tooling engineers here?" No. Well, who do you have? Well, we got two guys that are kind of industrial engineers. Hey, look, nothing wrong with industrial engineers, but you need somebody mechanical. You need somebody who understands tooling. You need somebody who understands. They had brought in new CNC equipment. None of the engineers had CNC experience. So, and by the way, that's not just one company. I'm talking about these. This is a repeated pattern that we have not matched our engineering talents with the type of business that we're running. Okay. Um, so, and we're almost always way under resourced. Almost always. Okay. So I've been hard on engineers because they're stuck in an office. They don't go to the shop floor where the real action is. Remember what I said about Chihiro Nakao, my sensei from Shingijutsu, from Toyota, one of the originals that worked for Ono. He said the main job of a manufacturing engineer is to make the life and the job of the operator easier. Period. What does that mean? That means we're going to be looking at ergonomics, the stress that goes through, the complications that they have to put up with. Okay. Are they still changing out a fixture with a Allen wrench, a manual Allen wrench? Why do we have fasteners to begin with? Are we allowing the operator? I just observed this in a recent client of mine, bending way over into a CNC piece of equipment to fixture the part. Totally, those operators are going to have back problems if they don't already. Okay. What about a nice simple Hanadashi device that presents the fixture to the operator, where he just loads it and pushes it in, or hits a button and it goes and it loads itself. Okay. Um, so we've got engineers in the office. That's what episode 72 was about. Where are the engineers? They're behind what my father used to call a boob tube, which is probably what you're watching this on right now, a computer screen. My father called it a boob tube when we had our three channels growing up, and I'd be watching some kind of TV show, and he said, "Hey, you're watching a boob tube. You're not learning anything by watching this idiotic stuff." Okay, well, engineers are married to their computers. Okay, and many of them, as Nakar would call them, are catalog engineers that go out and buy solutions instead of using their brain and creating something that is defendable in the marketplace and gives you a competitive advantage. I'll talk about that in a little bit later in this episode about moonshine. Okay. They love to create toys. I was at one company that created this unbelievable contraption. That's I think what I really have to call it, a contraption that was so complicated just to pack a bunch of parts. Okay. And if it ever worked, so many things had to go right for this thing to work. Okay. But it was an engineer's dream. They love working on this stuff. And that wasn't even where their strategic problems were in that factory. It wasn't in packing, it was upstream. Okay. So they love to create toys and they love to buy, battleships. I've been hard on equipment vendors. If you don't realize this now, equipment vendors are not your friend. They're not your friend. They lock you out of programs. They threaten you with warranty if you make any changes on your own. They'll charge you for the smallest little change. Okay? They sell equipment that isn't lean. They want you to have long changeovers.
They want you to have tougher times maintaining your equipment. Why? Because you'll eventually come back to them saying, hey, I need another increment of capital. And guess what? You buy the machine and they make their commission. Okay. So I'm going to talk about capital equipment guidelines at the end of this podcast. And I did have an episode on that. And I'll tell you about that in a bit. Okay. So we've got a lot of waste in the equipment that we buy. As a rule of thumb, I don't always like these rule of thumbs, but as a rule of thumb, a good lean company should be spending less than 2% of revenue on capital. Okay. I see 5%. Even Danaher now, last time I looked, it was 5%, 6%. I was with a company just recently, 10% of revenues on capital. We actually went into one of our clients and got them to stop building a new facility and basically eliminated their capital spend of new equipment that was roughly 20% of their revenues. They were going to spend that much money on capital because they think they needed this capital. But through what I'm going to talk about today, we got out all the waste and increased their capacity by 40%. Same footprint, same machines. Okay. Equipment's not conducive to ergonomics. We make the operators do all kinds of tricks. If you guys are familiar with Cirque du Soleil, I don't know why these operators aren't working there doing tricks in front of audiences instead of making parts. We ask our operators to do all kinds of crazy things. Okay, and then we wonder why we have all these safety claims. No Hanadashi with an automatic unload, right? Simple. No Chaco Chaco, which is load. So many processes are so easily set up for a Chaco Chaco line, but we don't do it. Okay. The operators stand in front of the equipment and watch the part run with no standard work sequence and no use of one of the three elements of standard work, which is standard work in process. The part allows the operator to continue after he cycles the machine to walk away and unload and load the next part in a one-piece flow cell. I see this all the time. I was just at a client where the operator just stands there and watches the part run. And I ask why, and I always get this answer. The answer is, oh, in case something goes wrong with the equipment. Look, something's going to go wrong with the tooling or the equipment regardless of whether he's standing there. He's not going to prevent it. It's like you standing in front of your clothes dryer watching the clothes dry. You don't do that. You walk away and you go do something else, right? But this is what we got out there, okay? Incredible travel in tool change. We somehow think that we, in a CNC program, which is highly repeatable, um, have to bring the tool, 3 feet above the damn part to change it out. Why? Oh, we don't want to crash the machine. Well, technically, you could bring it 2 inches above the die and you're not going to crash the machine. These CNC programs are repeatable to that precision. Otherwise, why the hell are you using them to make your part if they're that inaccurate, right? I see it all the time. I see it all the time. I actually saw one operation. Not only did they bring the tool about 2 or 3 feet above the part, but they pulled out the 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 uh, the fixture and moved it over to the side. And I said, well, why did you do that? Well, because we want to make sure we have enough clearance. Clearance. First of all, you bring the thing up 2 feet, 3 feet, and now you take extra cycle time moving that platform over, and then it's got to move back again after the tool change. This is ridiculous. Nobody has the notion that we're in a race, just like with Formula One or NASCAR. We are in a race to compete, and we're talking about bringing our costs down, bringing our capex spending down. This is why this stuff gets bloated. Okay, and by the way, I see it all the time. Dies are cutting air. So now that we got the tool up 2 or 3 feet above the part, it's just cutting air. It's coming down and cutting air. Okay. It only adds value when the tool hits the part. Same with stamping machines. We position our dies a good foot above the part. And when you look at it, these stamping machines are ba-boom, ba-boom, ba-boom. And it doesn't look like it's a lot of time. But if you take 90% of that cycle and do the math on the millions of parts that you make a year, you're going to find how critical that really is. Okay. So, I mean, I've seen, I was just in Europe at a company and they actually had a robot. And there's another pet peeve of mine on robots. So many misuses of robots. All this robot did was hover over a mold in an injection molding machine. The mold opened up over a meter wide just because the robot would not fit in between the molds. And all the robot did was grab the part, bring it out, and drop it in a box. That's all it did. Why not a simple Hanadashi that blows off the part from the mold down below? It's free. Gravity is free. Get rid of the robot. They were proud of their TPM program on the robot. Why the hell are you going to do a TPM program on a robot when you don't need the damn robot? And the crazy thing is, the robot consumed 40% of the floor space of the whole molding footprint. It's mind boggling to me. People get enamored with these toys. All you're doing is using this robot to pull a part out of a mold. You can easily set a Hanadashi with a little bit air blowing that part out right into the box below. Okay, so it's these kind of things that we see here, and we don't challenge them because we're not trained to look for these things. Okay, we're trained to look for yellow lines on the floor, and posters and Gemba boards, and focus on the Gemba walk. How many Gemba walks have you been on where anybody challenged the speeds and feeds of a piece of equipment? I'll bet you haven't been on those. I bet you nobody has picked that up. And if they have, God bless them. Okay, but I bet you the number is low. All right. Matter of fact, this one company I'm talking about had a 70% capacity opportunity, and they had this big capital spend in the next year that they're going to buy more molding equipment and robots. And I told the chief operating officer, you don't need to do that. You can get rid of these robots, tighten everything up, free up your floor space. They were going to build a new building. Why? You don't need to do this if you're looking at the things I'm talking about. Now, you might say, come on, Mark, 10, 15, 20 seconds here and there. What's the big deal? Okay, let me do a little math for you. Okay, let's just say we were able to take 15 seconds out of a piece of equipment per part. Okay, when you look at all the tool changes and speeds and feeds, and by the way, 15 seconds is low. I'm using a very low number. So we take 15, seconds out. Let's say you have to make 100 parts a day, and you got 3 shifts, so that's 300 parts a day. When you do this math out, that comes out to 4,500 seconds of cycle time that the machine is waiting. Well, it's not cycle time, but it's wait time. Okay, 4,500 seconds a day, and if you're working a 250-day calendar, it's 1,125,000,000. I'm sorry, 1,125,000,000 seconds a year, which is 312 hours of productive time that you got programmed and locked into your equipment, into your programs, the machine cutting air. Okay. What does this mean? It means that it's a tremendous impact on your capital equipment. It's a tremendous impact on your changeover time because by tightening up these wasteful movements, you're giving yourself more time to do more changeovers. And you've heard me say before that, the more changeovers you do, the better. Okay? The more changeovers, the better. Chihiro Nakao, go back to him, my mentor. He said, how many hours does this plant spend on changeover? We said 10,000. Now, your accountant's going to look at that and say, yeah, we got to make that 5,000. That's too much. Run longer batches so you don't have to change over. Dumb, 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 dumb. Nakao says, I want you to still use 10,000 hours, but do 10 times as many changeovers in that time frame. And what he was telling us was we have to drastically reduce our changeover time, do more changeovers, because we will then better match our production schedule to the way our customers consume and demand our product. Lead times come down, and I've got a mathematical formula I could send you to show you how a 50% reduction in changeover time is a 50% improvement in your Kanban inventory for that process and its related lead time. I'll be happy to send that model. Matter of fact, I did an episode on that somewhere way back. I can't remember which one it was, but I'll be happy to send you that model. Okay. Assuming you're going to try to make every part every day. And you could see the impact. Not only will you see the impact on changeover time, but if you reduce your cycle times, that also has a impact on the available time it gives you to do changeover. So, this is what we're looking at here, right? So, back in episode 8, all the way back in episode 8, and by the way, I'll be happy to send this to you as well. I'll give you my email at the end of this. When I was a CFO for George Conan Saker and Art Byrne at Danaher's Jake Break, before I got into manufacturing, and before then I went to, run the Danaher Business System office and architect what we now call DBS. I got rid of all the traditional financial measures. Matter of fact, I think many of you know I am the quote unquote father of lean accounting. Uh, and lean accounting, we didn't sit there and say, hey, let's invent lean accounting. We just did what we thought was right. A lot of what we did at Danaher was stop doing stuff, not doing something different. Just stop. I guess that is doing something different, but we just stopped doing dumb stuff. That once we understood the principles of lean, we just stopped doing the things that were preventing us from getting there. And traditional cost accounting was one of those things. Direct costing and value stream costing was what we did. Got rid of these overhead allocations, which nobody understood, not even the accountants. Okay. And so what I'll talk about now, part of that, besides target costing and new product development, value stream costing, I'm going to talk about how we looked at capital. Okay, because capital, I, I think I said on what episode was that? Episode 20, sorry, episode 8, all the way back to episode 8, I talked about CapEx. Okay. And when I first took over as CFO for Koenigsegger, I took 1 year's worth of capital appropriation request, and on the request had a box said annualized savings. I added up all the annualized savings that we're going to get out of this capital spend, and uh, it came out to be greater than our cost of sales for the year. So I joked and went back to George Koenigsegger and said, "Hey George, we should just stop making Jake breaks and just go and buy capital equipment. Look at the money we're making on capital equipment." Okay. And, we were using inflated overhead rates and all kinds of erroneous assumptions in buying battleships instead of small rowboats or PT boats. Uh, okay. Buying battleships that locked us into long cycle times, that pushed us onto a second shift because we couldn't meet attack time on one shift, things like that, right? Long changeover times, and extremely difficult to maintain the whole thing, right? So I changed our CapEx guidelines. And you're going to notice that nothing on here says return on investment, net present value. EVA was really big back then, economic value added, all these measures, right? I got rid of them. Yeah, I was a CFO and I got rid of them because they led us to the wrong conclusions. Okay. You can't look at any one piece of equipment with a lean mindset and say that piece of equipment alone is going to provide value if it's not in concert, A, with lean principles and the cell that you put it in. You've got to look at it as a part of the whole solution, right? So here are the questions when I was presented with a capital appropriation request. We call them capex or CARs, capital appropriation requests, CARs. My first question is very open. Why do you need a new machine? Okay. And you just sit back and listen to the answer. And you get all kinds of things. Okay. Well, because that machine leaks, it's old, it's this, it's that. They give you all kinds of reasons. And by the way, there are some legitimate reasons, right? But let me tell you about old machines. New is not necessarily better. We were at one of our acquisitions in Danner, and I was with Nikau again. And an engineer came up to him and said, Nikau-san, we need a new machine. And Nikau asked that first question. He said, why do you need a new machine? The engineer said, well, the machine is really old. How old is the machine? The engineer said, it's 15 years old. So Nikau shook his head and he said, okay, well, how old are you? He goes, I'm 32. And Nikau said, looks like we need a new engineer too. Okay. So they couldn't stand the excuse, I need a new machine because it's old. Matter of fact, when I was running the operations for the Asian business, I went to Hino Motors, part of Toyota, and they were one of my clients. And I wanted to see a similar machining line, so they showed me a connecting rod line, and which was phenomenal. It had Jidoka, poke yoke. You could not. I asked the engineer, "Where do you put your defects?" He says, "Delizio-san, we don't make defects in the cell." And as I got to learn what they did in that cell, I saw that if you wanted to make a defect, you would not be able to. Okay, that's a good challenge for you, by the way. See if you can make your own defect. Okay. If your process still allows you to, then you got to say, well, I didn't get it to where I need to be, right? But anyway, in that cell, in that connecting rod cell, with my engineer and I, we spent the whole day there. The youngest piece of equipment was 10 years old. Okay, the youngest piece of equipment was 10 years old. All right. The next question I asked: is there an alternative? Can we do something else? I was just with a client and they had a process that turned apart inner diameter and outer diameter. And together, the cycle times of those equipments, those two pieces of equipment, was well under tack time. Okay. We had like a 500 second tack time. And I think the total combined machine cycle time was 280 seconds, something like that, right? So I asked the question, I said, why can't we fixture a part to do the inner diameter and the outer diameter all in one machine? Since we're so under tack time, we had freed up a piece of turning equipment, which they were planning on buying another one in their capex budget for next year. Okay, and they gave me all the reasons why. Well, the way we fixture it, we can't get into the ID totally because the fixture's in the way. Well, is there a way that we can think about redesigning the fixture so it's universal, and not only for this size part, for maybe some other parts as well that are similar but different sizes, and and be able to fixture one time, one load, one unload, and do both ID and OD. And this engineer, to his credit, he said, I got about four different ways in my mind that I think we can do that, and I'm sure one of them will work. I love that guy. he he his name was Sid, and I called him Moonshine Sid. I gave him a nickname because he had that alternative attitude. Like, let's go back and experiment. Let's go see what we can do there. I like that idea. Let's see what we can do. Okay, that's the mindset you need. This kid had some really good talent, but he also had the right mindset. You can have talent and not the right mindset, and you're sunk. So anyway, is there an alternative? Um, Tell me about the kaizens you did on the old machine. Did you take out speeds and feeds? Did you try to improve changeover? Or whatever reason you're giving me as to why you think you need a new machine. Okay. Will the new equipment meet your tack time? Okay. Now and in the future. I remember setting up a cell with a client, and let's just say the tack time was 2 minutes, and each of the five machines in a one piece flow environment met tack time. Okay. I don't know. a year later or so, I came back and the engineer said to Mark, "You gotta go see our new piece of equipment that we bought in that cell that you created last year." And the first thing in my mind is like, "Oh boy," red flags went off, and I'm like, "Oh boy, okay, let's go see what they got." There was this huge battleship of a machine, and Mark, the 10 the 10 minutes of cycle time that your cell had when he added up all the cycle times of each of the five pieces of equipment. Let's just argue they were 2 minutes each for math's sakes, okay? They weren't even, but we can now do that whole 10 minutes in 6.5 minutes. Really? Well, congratulations. On one machine, you do it in 6.5 minutes instead of five machines that has a drop off rate of tack time, 2 minutes. So I asked the first question. I said, "What's your tack time? Did it change?" "No, it's still around 2 minutes." So I looked at them and I said, "Well, how's your second and third shift doing?" "How did you know we had to put a second and third shift on?" "Because your frickin' tack time's 2 minutes. Your cycle time you just got through telling me is 6.5 minutes. You can't make all your parts on the first shift like we were in the other cell. You just put yourself onto a second and third shift. Come on, guys. You know? And you're probably working weekends because I'm sure this thing doesn't run all the time. I'm sure you got long changeovers. And even at 6.5, you don't have enough hours in a three shift operation to do it in 5 days. Let's do the math. Okay? So here's a case where the engineers got really enamored with all the bells and whistles on this big piece of equipment, and some machine vendor came in and sold it to them, never asked what the requirements were, never asked what their tack time was, because he probably didn't understand what tack time is. Okay? I'm telling you right now, machine vendors are not your friends. And these engineers that want to go out and buy these large pieces of capacity are enemies of your company, and they need to change. Okay? Now, I'm going to talk about moonshine concepts in a minute, right? And we'll relate back to this particular story. Have you prepared a process capacity analysis for the new equipment? Is it capable, okay, of meeting your capacity? It's similar to does it meet tack time, right? Will the equipment fit into a flow cell or will it cause you to batch parts? Will it bring you to a batch operation? What is the changeover time? How will you assure quality in this machine? Now that you're doing everything in 6.5 minutes, I no longer have five checks after each process. Okay. Are you checking the process internally? Okay. There's all kinds of probes that you can use to do that now. You don't even need to use a CMM. All right. A Renishat probe. John Boucher, who I think is the greatest moonshine guy on the planet next to Nakao, works for Lean Horizons. And he put these Renishat probes in, and it checks quality along the way. It's built in quality. Okay. So what is a changeover time? How are you going to assure quality? What's the CPK, not only of the equipment, right, but of your whole process, right? What are the technical capabilities and resources that we have to add? Hey, this saved three operators. Okay, great, but we had to add two technicians at three times the cost. Okay, that have to program these robots and these other pieces of crazy equipment that we seem to buy. Um, and can it be maintained without the interference of the operator? I was just with a client not too long ago, and their equipment was separate. They created what they call the cell, but the equipment was separated by about, well, I don't know, 4 or 5 feet, which meant the operator had to walk that distance and multiply by two because they have to walk back. And it's all because of maintenance. The way the door opened, it opened wide, and they needed clearance with the next machine for the maintenance guy to get in. I said, well, can't you re-engineer these doors so that they slide up, or put what he needs to do towards the back of the machine, and get your coolant in all your other equipment, ancillary equipment behind the machine, so that you reduce an operator walk time. Okay. So these are the kind of questions that we ask. So those are the questions we would ask on a capital appropriation request. No ROI, no net present value, none of that crap. I don't know how you take ROI to the bank. I challenged the CFO a couple of months ago. Hey, I want to get in your car and I want you to take me to your local bank, and I want to see you write a deposit slip for ROI. I'd love to see that. I'd love to see you do that. Okay. Of course you can't, right? So um, that's way back on episode 8. The whole issue with capital appropriation requests. Matter of fact, the episode was called "CapEx Through a Lean Lens." Okay. Now, and again, I'll be happy to send that to you too. That guideline. Um, we talked about moonshine on episode 28. A little bit of background on moonshine. Chihiro Nikau, who I've talked to on this podcast and others, this episode and others, was our sensei, and he was different than most of the Shingijutsu consultants. Matter of fact, he was different than all of the Shingijutsu consultants. He is known as the father of moonshine, FOM. Matter of fact, he makes his son call him that. and why moonshine? For you people in outside the United States, you heard our racing that's really big here is called NASCAR. Okay, and back in Prohibition, when it was illegal to drink alcohol and own alcohol, uh, all of these moonshine stills popped up in the backwoods of places like right here in North Carolina, where I am. Okay. Matter of fact, North Carolina is the home of NASCAR, right? And all throughout the South into, Georgia and South Carolina and Florida and all different places. And the moonshine distilleries that were created with garbage cans and garden hoses and stuff like that, right? Anything you get your hands on. So the cow had the idea of, hey, we need to create our own equipment in a similar fashion, which is where he got the idea of moonshine. And by the way, just a little side note, NASCAR got invented because the people who ran these moonshine stills had to have automobiles that were faster than the local police and sheriffs. Okay. So that they had to escape across state lines. And once you're across state lines, for example, from North Carolina to South Carolina, if you're being chased by a North Carolina uh, uh, police, sheriff, state cop, whatever, once you cross the South Carolina line, he can't touch you. Okay. So they had to come up with these cars that were faster so that they could escape the police. That's where NASCAR got born, believe it or not, right out of the whole moonshine thing. But Nicole really glamored onto the whole moonshine. There's a lot more to it, too. Matter of fact, we did an episode on moonshine with John Boucher way back in episode 28. And I'd encourage you to go look at that. But here's the idea moonshine, in the moonshine room, the engineers go in, management's not allowed, no schedules. They go in and they contemplate how to build your own equipment that meets all the criteria I talked about with with the capex spend, right? And you create these Chaco lines. You create um, Chaco lines. You create Hanadashis, quick changeover, even no changeover, that type of thing, right? And the concept is this: if you and I are competing against each other in whatever business, you and I can go out and buy the same materials. We can go and buy the same labor, and we can also go out and buy the same equipment. And I guess it is what you do with that equipment that's going to give you the strategic competitive advantage with quality, reduction of lead time, and all that stuff, right? Well, when you do that, we can go out and buy equipment, and I can do a great job on changeover, and I can make improvements, and that will be an advantage for me short term, couple 3 years until my competition figures out how to do it as well. But if you build your own equipment that takes all of the institutionalized waste that equipment vendors put into this equipment and create it on your own, taking a stamping press that's as big as the house to make a little part, then all of a sudden you say, you know what? My whole idea is I want to make a machine that's no bigger than the part that it makes. Now, maybe you won't be able to get down to that, but you can reduce the footprint and the size of this equipment. Take a look at your parts and take a look at how big the equipment is. And ask yourself, why do I have this big piece of equipment making this small little part? I see it all the time. Okay. So so you create moonshine and you develop flow, you develop low or no changeover, you build in your quality, you've got your ability to flex your capacity up and down as your takt time changes. All right. You're taking all the waste out and all that, but you're building it in. Nobody in the world will have that capability if you build it yourself. And you just created an unbelievable competitive advantage. Now, with one client we're dealing with, they were not only going to buy all this extra capital and create another facility, which we stopped them from doing, but they were going to go out and acquire their competition. And I said to the managing director, "Why would you do that? You don't need their equipment, you don't need their people, and you don't need their facility. Why would you go buy them? Why don't you just take their market share? Because you're selling to the same customers, same OEMs. So what? Why don't you just go to those customers and say, oh yeah, by the way, my lead time now instead of 24 days is 2 days. That's what we got them down to. And you don't not only have to carry the inventory, we're going to be as flexible as hell. You call us at 9 o'clock this morning, we'll have something for you this afternoon. We'll be that flexible for you because our lead times are so low. And oh yeah, by the way, our quality is better than anybody because we built that into our process. Guess what? Who are they going to give the business to? Especially if you're selling to distribution, who gets measured on GMROI, gross margin return on investment. What do you think the biggest investment is? It's inventory. I talked about the fact that we did this with a temperature controller business in England, and we went from 28 days down to 3 days lead time, and we beat the pants off of Honeywell and Siemens, who we were competing with. Small little company in Brighton, England. And their volume went from 30,000 units a year to 110,000 units in a year just because we were better suppliers. Our, our customers didn't have to keep all the inventory. Our quality was better, and we beat all the big boys. Okay. So you could turn your equipment into a strategic competitive weapon. Obviously, you get your salespeople to be able to know how to sell it from a value selling perspective. But by the way, the latest episode I just did with my friend Randy Fitzhugh from Danaher, he's now consulting, and we talked about value selling and how you actually take all these newfound capabilities that you create with lean and not only win business, but even in a commodity business, you can get price. You can get price. So that's why this is an enterprise-wide business system. It all ties together, right? It wouldn't do you any good to reduce your changeover times by 90% if your sales guys don't know about it and don't know that and nobody has the wherewithal to go in and change lead times, okay, with the customer. And we're still thinking along traditional ways because we haven't tied everybody in. So anyway, how do you get real breakthrough on this? Well, first of all, you could start with your existing equipment and do the things I just mentioned, okay, with speeds and feeds and all the other stuff. But ultimately, you want to get to a point where you're building your own equipment. And that's where moonshine comes in. And we're going to be doing a lot more on moonshine. As a matter of fact, we're going to be putting together a course for moonshine. Nobody out there is doing that. And if they are, they don't have the skill and talent to really do it. I know the players out there. And I feel, John Boucher, for example, to me is the best I've ever met in terms of engineering and in terms of the whole moonshine methodology. Okay, and he's got the track record to prove it. Started out as a tool and die apprentice, and worked his way all the way through all the engineering degrees and everything else. And then he basically was Chihiro Nakau's protege when it came to 3P and moonshine. Okay. So we're going to be doing a lot more on that. And so stay tuned for that as time goes on. Okay. Uh, Mark at lean Mark at lean911.com is the email, Mark at lean911.com. And I'll be happy to send you the changeover model that I talked about earlier, and also the CapEx guidelines. Okay, and you can get those off of episode 8, going all the way back to that, because I do show those guidelines on that episode. But if you want me to send you the PowerPoint slide on it, I can easily do that. You got to get your CFOs on board though. Okay, if you don't get your CFOs on board with this, forget it. Okay, and I have all kinds of episodes on that. Matter of fact, episode 78, the CFO versus lean, the fight that gets lean leaders fired because CFOs don't get what we're doing. Their heads are stuck in traditional financial management, and they don't understand how detrimental their mindset, processes, and measures are to a lean transformation. So if we don't get that fixed, okay, then it may not matter, right? Because you'll run into roadblocks that I talk about on episode 78. Okay, I hear my dog barking in the background. It looks like he's ready for lunch. Uh, but and I guess so am I. But anyway, thank you very much. Again, episode 81. Your machines are lying to you, and so are your equipment vendors. The hidden waste most manufacturing engineers ignore. Check it out and email me with any questions. And if you want those files, let me know. And God bless. Thanks for listening, and stay lean.
Thanks for listening to the Lean 911 podcast. I'll be happy to address your questions or feedback on future episodes. Email me at mark@lean911.com. You can check out our other episodes by visiting our website at lean911.com, our YouTube channel, wherever you listen to podcasts. This is your host, Mark DeLuzio. Thanks for listening.